Okay. So we'll start with metals and non-metals because diagram is very much important there. Scoring also important, no, in exam, right? That diagrams, labeling everything and come. Then we'll do those remaining part. Metals and non-metals we'll study about. And metals and non-metals also one of the important chapters. Okay. Metals and non-metals also important chapters. So about in this chapter, metals and non-metals. So we will study about the mainly the chemical properties of metals and non-metals. Okay. So in the metals first, we know we'll just revise about the physical properties, then we'll go for the chemical properties. Okay. So metals. Huh? What? Still too much of time is there. Why? In the page, where you will write. In the book only write and come. Continue, no, fine. You finish that, then I will. Okay, don't worry. Tell me now. Don't no worry. Write in the science book. That is enough. Metals or non-metals. First, we will study about the physical properties. Physical properties. So, what are the physical properties of the metals? Metals are metals are lustrous in nature. Metals are sonorous, ductile. Metals are malleable in nature. Then metals are good conductors of heat and electricity. Then metals are electropositive in nature. All these are there. So, what are the properties of the metals? Metals are conductors, good conductors of heat and electricity. Then metals are lustrous in nature, that is shiny in nature. They are sonorous, that is when hit with any substance, they make sound. Okay, that is the one. Then they are solids. Most of the metals are solids in nature, but mercury is the only liquid metal what we see. Most of them they are hard in nature, but still we have the soft metals like sodium, potassium, and all. They are soft in nature. You can cut from a knife. Okay. Sodium and potassium. Listen here. Most of the metals are hard in nature. Example, iron is hard in nature. Correct. That is why it is used in buildings. Correct, construction of buildings and all, why we use, because it is hard in nature. Then metal, but if there are many exceptions, sodium positive, correct, non-metal. Chlorine is non-metal. Okay. So metals, like example, some exceptions will be there. Sodium and potassium, they are soft in nature. You can cut it from a knife. Okay, you can cut that from a knife. So that much soft it will be there. And mercury is the only liquid metal what we see. It is the only liquid metal what we see. And most of them metals are lustrous in nature. They are good conductor of heat and electricity. Since they are good conductor of heat, it is used in the utensils. Correct? No? Since it's a good conductor of heat, we can use it in utensils. Otherwise, you can't cook that in cook the food because it is a good conductor of heat. We can use in the utensils. Then it is good conductor of electricity also. That is why we used in the wires. Example, copper wires. So copper wire is used. Why? Because it is ductile in nature. You can draw it into thin wires. So that is the ductile property. Because of that, you can make it as a wire, and it is good conductor of electricity. That is why it is used. And the outer covering usually will be plastic in nature. Why it is plastic in nature? Because it is an insulator. Correct, no? So when it is insulator, if you touch that also, you will not get shock. So that is why it is used. So if you know the properties, you can use that. Because of that, it can be used. Then what else is there about the metals? It will melt rubber very easily. No, that is why. Okay. So metals we studied. Then there are non-metals. Correct. What are the properties of non-metals? What are the properties of non-metals? uh, dull non-metals. Non-metals are dull in nature. Usually they are dull in nature. Then non-metals are non-ductile, non-malleable in nature. Then non-sonorous in nature. They are bad conductor of heat and electricity. Okay, they are bad conductor of heat and electricity. And most of them, they are gases, few are solids. Which is a liquid metal? Liquid non-metal. Bromine is a liquid non-metal. Okay, liquid non-metal. But there will be exceptions. For example, graphite is there. Graphite is what? It is made up of carbon. Carbon is a non-metal, but graphite is a good conductor of electricity. Okay, again I repeat, see, listen here, these things they ask. In non-metals, most of them are bad conductor of electricity, but there will be some exceptions like graphite. Graphite is a bad conductor, good conductor of electricity. For example, we use in electrodes. Graphite rods are used as electrodes. In uh, do you remember? Okay, it is used as electrodes because they conduct electricity. So graphite is an exception where it is a good conductor of electricity. Then diamond, most of them gases or few are solid. Okay? But diamond is a solid which is the hardest substance, which is a non-metal. Okay, so that is also an exception. We see that. And another one, what about iodine? What is the exception? It is lustrous in nature. Iodine is lustrous in nature, but most of the non-metals, it is dull in nature. So all these also they ask. Okay. So these are the properties of metals and non-metals. And in this chapter, we will briefly study about this. Then we study about the chemical properties. So what do you mean by chemical properties? Chemical property means how they react with the air, how they react with the water or with base, acid, like that. With oxygen. Air means oxygen only, usually they take. Okay. So all these we will try to learn by studying the chemical properties, how they react. Okay. And metals are electropositive in nature and non-metals are electronegative in nature. Electropositive in nature means they will be tend to give the electrons in a chemical reaction. Metals, they tend to give the electrons in a chemical reaction. So they become the positive ions. They become the positive ions. And non-metals are electronegative in nature. That is, they ready to take the electrons. They're ready to take the electrons. That's why they become the negative ions. Okay. So this is also one of the basic property from which they bifurcate between metals and non-metals. Okay. This is also one of the basic property by which they can bifurcate metals and non-metals. For example, why they are electropositive in nature? For example, if you take sodium, okay, it is 11. See, in chemical reaction, what are the one which takes part? It is the electrons. See, protons and neutrons will not come out of the nucleus. Only the electrons which will take part in the chemical reaction. Only the electrons are the one which takes part in the chemical reaction. Okay. So electrons, how much is there? In a sodium, it is 11. Okay. So that means what? 281 will be there. Okay. And we know the octet rule. Correct? We know the octet rule. That means what? In the outermost orbit, most of the, like in all the, they try to become 8 electrons. Okay. In the outermost orbit, it try to keeps the 8 electrons so that they become stable in nature. So in the sodium, it is easy to give out 1 electron to become 8. If it gives out 1 electron, it becomes 2, 8. Correct? No. But if it gains, if you want it to gain the electrons, it has to become like this. That is 7, it has to take. So to take 7, energy required is more. But giving 1, it is easier. So it tends to become electropositive in nature. Okay. All the metals will be like that only. Even the magnesium, in the outermost orbit, 2 electrons will be there. Okay, so it will tend to give 2. Even in the calcium, it is like that. two electrons will be there in the outermost orbit, so it is easy to give. Whereas when you take the chlorine, non-metal, it is 17 is there. Okay. So 17 is there, 2, 8, and 7. So 7 is there, 1 easy to take then rather than giving 7. So they are electronegative in nature. Okay. So how much it can take or how much it can give in a chemical reaction, that is only the valency. So if it is giving, we tell it as +1 valency. If it is taking 1, we will take it as -1 valency. -1 plus they would have written on the book. That is the reason. Okay. Again, I repeat these things, see, because it helps lot in like understanding how the compound is formed. So sodium or any example, metals are electropositive in nature. That is, they tend to give the electrons to form the octet rule. That is, 8 electrons in the outermost orbit. They usually have 1 or 2 electrons in the outermost orbit, which it can give easily. So they tend to become electropositive in nature, whereas the non-metals are electronegative in nature. That is, they tend to gain the electron. Okay, in the outermost orbit. If you take oxygen, is also a non-metal. In the outermost orbit, it has 6. So it will easily, it can take 2 like that. Okay, easily it can take 2 electrons there, like that. So metals are electropositive in nature, whereas the non-metals are electronegative in nature. This is also one character. From one characteristics, we will try to bifurcate metals and non-metals. Okay, and metals are basic in nature. Few points I'll tell so that when we write chemical reactions, it is easier. Metals form basics in nature, basic oxide. For example, sodium combining with the oxygen, sodium hydroxide. Okay, like that. Calcium combining with the oxygen, it forms calcium hydroxide. So, metal oxides means what? Metal combining with the oxygen, they form metal oxides. Okay, so metal oxides are basic in nature. Metal oxides, they are basic in nature, whereas non-metallic oxides, they are acidic in nature. Example, carbon dioxide is there, sulfur dioxide is there, sulfur trioxide is there. All these are non-metallic oxides. Non-metallic oxide means non-metal combining with the oxygen. They form non-metallic oxide. Some basic things, if you know, it is easier. That's why I'm doing. Oxide or hydroxide, anything combined with oxygen. That's it. It's fine. Just an example I'm giving here. Here I'm telling about oxide only, because all these contains only oxygen. Okay, so non-metallic oxides are acidic in nature. Example, carbon dioxide, sulfur trioxide, nitrogen dioxide, anything like that. So they are acidic in nature. Okay, this is how we bifurcate metals and non-metals chemically also. All metals, write down this, all metals. Okay, write down now all metals except mercury, okay, exists as solid in room temperature. In room temperature. Most of the metals, most of the metals to tie and come. Okay, most of the metals are hard in nature. So, what are the exceptions you have? Exception, potassium and sodium, they're soft. Potassium and sodium are soft metals. They are soft metals which can be cut from the knife. which can be cut by knife, which can be cut by knife. Uh, Most of the metals have high melting point, high melting point and high boiling point. So what is the exception for this third one? Then other than that, gallium, that is also an example where it is melting point is less. Exception what we can write? Gallium. Okay, have low melting point. They have low melting point. Low melting point. Okay. So these exceptions you should remember because they ask in that more questions. Okay. What type of questions are you trying they will tell substance X can be cut by a knife, write a compound of the, or like that. They give some clue. They will ask what is the compound, tell the uses of that, something. Lead. Lead it is two, I think. Then we have metals are ductile and malleable. And silver and gold has the highest ductile and malleable property. The metals are ductile and malleable in nature, right? Ductile means it can be drawn into thin wires. Malleable means they can be drawn into thin sheets without breaking. Example, aluminium foil is there. What they use, that is a very thin sheet of aluminium. Why we can make it into aluminium foil? Because it has the property of malleability. And gold and silver has the highest ductility and malleability. They have the highest ductility and the malleability property. Okay, right. This silver. Then comes the gold. Thin sheet. Correct. Gold has the highest malleability and ductility. Then comes the silver. Right example here. Right example for gold. Write this. Gold is the most ductile metal. Most ductile metal. Okay. Then comes the silver. Ductility and malleability. Gold is the most ductile and malleable also. Then comes the silver. And it is having the so much good property that from 1 gram of gold, you can draw it into 2 kilometers wire. So much thin you can make without breaking. Okay. So from the 1 gram of gold, you can draw it into 2 kilometers of wire, length wire. So much it has having the ductility property. That is also gold. Next comes the silver. When it comes for the conductivity of electricity, silver is the best conductor. Then comes the gold. Metals are electropositive in nature. Electropositive in nature. Then metals are good conductor of heat and electricity. Metals are good conductors of heat and electricity. About non-metals, you write now fast. I'll come and check. After this, write non-metals characteristics. Right? AU gold. Okay. Potassium, sodium, calcium, magnesium, zinc, iron, lead. Yeah. Hydrogen, copper, mercury, silver, gold. Yeah. So from most the reactivity series, we are writing from most reactive to the least reactive metals. Or and even hydrogen we write, we compare with the hydrogen there. Actually, that's why we write that also. So potassium, it is the most reactive metal, whereas the gold is the least reactive metal. See, gold price is precious, right? Gold we think it as precious. The two reasons is it is the least reactive in nature. Diamond is not a metal. It's hydrogen is not metal because to compare we want that. That's why they use that. Okay. So diamond also they don't react. Where it reacts? Have you seen diamond reacting? So potassium is the most listen. Potassium is the most reactive metal. Okay. And next comes the sodium, then comes the calcium. It goes in that series. And gold, yeah, it's nature, man. Why you will talk more is what I can tell. It's even nature. That's it's nature, man. It's nature. Okay. Gold is the least reactive metal. Gold is the least reactive metal. Gold, why we call it as so precious means it will not lose its property because it is least reactive in nature. That is, it will not react with the water, with the air, even with the steam. It will not react. Okay, it will not react at all. That is the reason we call gold. It is very precious in nature because it keeps its properties. It holds its property. That is why we use in the ornaments. What is one of the reason is if we don't use the iron ornaments, right? Why? Because it will get rust. But gold, why we use? Because it will not get rust. It holds its property. That is why it is valuable in nature. One thing is it is getting gold also. It is difficult mining. Very less we get, but more than that because of its properties. That is, it is lustrous in nature, ductile in nature, malleable in nature, and also it is the least reactive one. Okay, that is the reason. And this reactivity series is very much important. See, potassium and sodium, it is so reactive that potassium and sodium that they just keep the potassium and sodium outside in the air. They get catch fire. That means they react so abruptly that with the air, and it is a so exothermic reaction. It will catch fire because of that exothermic heat produced in the reaction. Okay, potassium and sodium, no, they are most reactive metals. They are so much reactive that if you keep the potassium and sodium outside, they catch fire. Why they catch fire? They react with the air. Potassium and sodium, they react with the air, and it is so highly exothermic in nature. Because of that heat, they will catch fire. That is why potassium and sodium, they are kept in kerosene. They kept inside the kerosene so that they don't react directly with the atmosphere. Okay. And see, gold is the least reactive, which does not react with the oxygen, moisture, even with the steam, they don't react. That is why it is more valuable in nature. Okay. And see, reactivity series, first chapter, do you remember? We studied about displacement reaction. One metal will displace the other, or one element will high reactive metal can displace the low reactive metal there, correct? No. So now potassium reacting with any substance can displace like that. So by the reactivity series, we will know which metal can displace which. All these we will know by this. So once you know all these, when we do the reactions, you will understand. Okay.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.